Hello, everyone. Welcome to the Math Magician's Den. We are going to talk about limits here again today. And what we're going to do today is we're going to talk about limits that do not exist. And the first function we're going to talk about here is the limit as x approaches 3 of the absolute value of x minus 3 over x minus 3. And if you take a look at the graph of this, what happens here is as you approach 3 from the left-hand side, you can tell that all of these values are approaching -1. In fact, all of those values are -1. On the right-hand side, all of the y values are 1. So if you've watched some of my previous videos, you'll see that when I do this problem, if I'm approaching 3 from the left, it's going to approach -1. Now here's why. Give me a number that is really, really close to 3, but it's to the left of 3. And we're not talking about 2. Let's talk about really close. Let's plug in 2.9. So the top, 2.9 minus 3 is -0.1. And on the bottom, I'd get -0.1. But the top, I have an absolute value. So I get 0.1 over -0.1, and I get -1. Now, you could do that with any value that is really, really close to 3 on the left-hand side, and it's going to come out to be -1. Okay? Now, let's do it on the right-hand side. You saw that the limit approached 1 on the graph. Here's why. What's a good number to plug in that's just to the right of 3? Maybe we choose 3.1. 3.1 minus 3 is 0.1. Same thing top and bottom, except the top has an absolute value, which here doesn't really change anything. It makes it positive. It approaches +1. Now, we talked about, if you watched one of the previous videos, when you look at a limit, the left-hand limit up here equals -1, but the right-hand limit here equals 1. So we are going to say this limit does not exist. And what's my reason for this limit and it not existing? Well, what we're going to say is the left-hand limit did not equal the right-hand limit. That's the reason this limit does not exist. If your left-hand limit is not going to approach the same value as your right-hand limit, this limit is said to not exist. Okay? Let's look at the next example that I've got here. I've got 1 over x minus 1 squared. Okay? And we're going to take a look at what happens at 1. Take a look at this graph right here. If you look at x equals 1, there's a vertical asymptote there. And what's happening over here? The numbers on the graph are going up and up and up. Same thing on the right-hand side. The values of the graph are going up and up and up. Take a look at my table. The closer I get to 1, the value of c, the bigger those values get. So when we talk about the limit, as x approaches 1 from the negative side, this is 1 over 1 minus 1 squared. This gives me 1 over 0. Now here's the thing about this, is this 0, are those numbers approaching 0 from the positive side or the negative side? Well, what the heck do I mean by that? If you take a number that's a little bit less than 1, like 0.9, and you subtract 1, that's a negative number. But a negative number squared is always going to be positive, so this is not 0. These are positive numbers approaching 0. So what I do with my students, I always tell them, put a little plus beside the 0. Now, if you let a number on the bottom of a fraction get smaller and smaller and smaller and smaller, that fraction is going to get bigger and bigger and bigger and bigger. 1 over 0, when we talk about limits, this thing goes to infinity. And you saw that on the graph. The graph is going to infinity on the left-hand side. Okay? Now, how do we show this on paper here? Well, what I can do is I can take 1 and I can divide. Okay? And I'm going to put parentheses here. And I'm going to put x minus 1. And what we're going to do is we're going to square that. Now you notice what it does on the graph. Okay, it graphs it. But what we're going to do is we're going to start plugging in numbers here. We're going to plug in something really close to 1, like 0.9 on the left-hand side. Comes out to be 100. What if I get closer to 1, 0.99? Watch that number on the right there at the bottom of the screen get bigger and bigger. The more I make the bottom of that fraction closer to 0, the bigger that fraction gets. This is why it goes off to infinity. Okay? Now you'll notice on the other side, it's going to do the same thing. We're going to have basically 1 over, again, 1 minus 1 squared, that is 1 over 0. Give me a number that's a little bit bigger than 1. Well, how about 1.1? Well, 1.1 minus 1 is a positive number. A positive number squared is a positive number, but those positive numbers, again, are getting closer and closer to 0. 1 over 0, when you talk about limits, this goes to infinity. So what's going on with my two-sided limit? Well, this two-sided limit, if it goes to infinity on the right and it goes to infinity on the left, well, this must go to infinity. But that means this two-sided limit, this limit does not exist. It goes to infinity, but this limit does not exist. And the reason you're going to give, this limit is unbounded. Both sides or one side doesn't matter. Either go to infinity or negative infinity. This limit does not exist because it's unbounded. Now, this last example I'm going to show you is kind of weird. Sine of 1 over x. Take a look at this graph. We're going to look at the limit as x approaches 0. Well, how am I supposed to look at the limit as x approaches 0? When you look at this graph, it just looks like a clutter. Well, what we're going to do is we're going to go to this window key here on Desmos, and we're going to change the window, okay? I'm going to put in negative 0.1 to 0.1. Now, what I've done is I've zoomed in on this spot, and you'll notice it just keeps going up and down and up and down and up and down. Let's do it again. Let's make it go. Make these numbers even closer to 0. Look at this. It just keeps going up and down and up and down and up and down. And I think I could keep going with this, and you guys would notice there is no way to figure out what's going on here. It just keeps going up and down, up and down, up and down in tighter and tighter cycles. So what is the limit here? Well, the limit, it does not exist. Now, again, we have to have a reason for my limit not existing. Well, in this particular case, the reason for my limit not existing is because it oscillates. So we've really got 3 reasons why a limit does not exist. A limit's not going to exist if the left-hand limit doesn't equal the right-hand limit. A two-sided limit is not going to exist if it's unbounded, if it goes to infinity or negative infinity in any particular way. Or if the graph oscillates between 2 values, it goes up and down and up and down. It doesn't have to be the same 2 values. Okay? So it goes up and down. When I say the same values, it doesn't have to go 1 to negative 1. Maybe it goes from 1 to 5, 1 to 5, 1 to 5. Or it goes 1 to 5 to 2 to 4 to 1 to 5 to 2 to 4. That's an oscillating graph. And when it oscillates, the limit at a particular value does not exist. I hope this helps. If you like this video, please hit the like button. And if you think this is helping you, maybe subscribe to my channel. I appreciate it. I'll have more videos later on.